Hello everyone. So today I was going to discuss the 50 challenging problems in probability. Basically, I was solving these probability problems and I was just going to share my experiences, or if you're going to solve these probability problems or just going to practice these problems. So kind of hint or a reminder, or if you're just going to practice along with me, like after seeing this video, then it's well and good. So let's just move on to the problem. The first problem is sock drawer. So a drawer contains red and black socks. When two socks are drawn at random, probability that both red are drawn is half. How small can the number of socks in the drawer be? Second, how small if the number of black socks is even? So the probability that both is red is simple, like number of red balls upon total balls, and there is no replacement. So next time, number of red balls minus one upon number of total balls minus one. Very basic. And so how is equal to half. So how to proceed further? So, so here what we can do is we can start putting values. So let's say we can start with, let's say, possible number of red ball, black ball be 0, b1, b2, b3, 4, 5, 6. So here we can get how small can the socks be. And if the number of black ball is even, then 0, 2, 4, 6. This can be one of the possible methods. This is the way I've solved it, and yeah, you can also try this out. This is the second problem, successive wins. To encourage Elmer's promising tennis career, his father offers him a prize if he wins. Okay, at least two tennis sets in a row in a three series match to be played with his father and club champion alternatively. One is father champion father or champion father champion, according to Elmer's choice. And the champion is a better player than Elmer's father. Which series should Elmer choose? A very simple question. The question, the way it is defined, or the at least understanding part is simple. So what has do? Elmer has two choices. Either he can choose father champion father or champion father father champion game. Sorry, father champion father or champion father champion. Okay, and what is the condition is he had to win at least two tennis sets in a row, like two consecutive games. He at least, either he can win all three. Also, it's okay, but at least he has to win two consecutive matches. Okay, so which one should he choose? This is a very interesting problem. Okay, try to just go with the maths, basic maths, and try that all the possible cases for both the cases, for father champion father and champion father champion. You will try to get the answer. You will get the answer then. Go in the basic maths. And this is the flip and juror. So three-man jury has two members, each of whom can independently answer the correct question with probability P. And the third member flips a coin. After flipping a coin, he makes a decision. And the majority of these three rules. Okay. And the one hand jury has P probability of making correct decisions, which jury has better probability of making correct decision. So one is single jury, which has P probability of making correct decision, and another is a three-man jury, where two people have the probability of P making correct decision independently, and the third guy is just simply tossing the coin, and if the coins like say true or false, then if true is go for true, if false it go false. If it's certain heads, he go for correct. If other one, it go false. So which one is better? Which one should choose? We should choose. He also go for the same basic method. Okay, you will might get the answer. You will get the answer. Basic maths. Okay, basic maths means, let's say, one of the cases. Let's say we need at least two jury to win. Na? Let's say all three win. So all the case WWW, like all three win. What a probability? P for jury one, P for jury two, and half for jury three. So P square by 2 if all three wins. Simply, let's say if jury win give the like wrong answer, but jury 2 and jury 3, like sorry, guy 2 and 3, same jury 2, 3, give the correct answer. Or if jury 1, 2 is correct, third is wrong. Or jury 1, 3 is correct, second is wrong. All four cases, just try to write it down. We get the answer. Fourth question in, on the average, how many times must a dice be thrown until one gets 6? So how many times we need to throw a dice to get a 6? So here we actually asking on average. If there is not an average, how many times must a dice be thrown to get 6? We can't answer actually, but here is asking average. The average is basically expectation. So what we do in discrete probability questions, expectation is x px, x into probability of x. Or here x can be like how many times we must throw dice to get 6. So x can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to infinity. 1, 2, so x is equal to 1 and the probability of getting 6 in the first trial. So 1 into px is equal to 1. Second, 2 into probability of px equal to 2. 3 into probability of x is equal to 3. Same up to probability of up to n, and n into probability of x is equal to n, where x is a random variable. How can we define x? Number of times we must roll the dice to get 6. And let's say we must roll dice let's say 5 times. So what is the probability to get 6? So for the first, we roll dice 5 times. So for initial 4 times, it won't be 6. What is the probability? 5 by 6 times power 4 into 1 by 6. 5 by 4, sorry, 5 by 4, yes, 5, sorry, 5 by 6. 5 by 6 because 1, 2, 3, 4, 5. 5 faces on the dice. 5 by 6, keep power 4 because first 4 times into 1 by 6 for getting last 6. So in this way, try to write the equation for expectation, and then you will use the concept we use in 11th. Like if x is equal to something, then 1 minus x or something, we will subtract. Like in the APGP series we learn in class 11, use this concept we required. From there you will get the answer. This is an interesting problem to prove. And then the coin in a square. So here what we did is, so in a common carnival game, a player tosses a penny from a distance of 5 feet on the surface of a table ruled in 1 inch square. So this table, it is ruled in 1 inch square. मतलब table is divided into 1 inch squares, and the penny diameter is given, falls entirely inside the square. Player receives 5 cents, but does not get his penny back. Otherwise, he loses his penny. If the penny lands on a table, what are the chances is to win? This is very interesting problem. So what we're given is, there's a table. We had divided a table into 1 inch squares, and a guy is just throwing the coin on the table, and we need to calculate that what is the probability that the coin completely lie inside the square, like it does not fall on the edges, or yeah, to fall at the edges or in the center corner. It just must completely lie inside any square. Are you getting the question? Like this is very interesting problem. I have to think of this, spend some time, because this is, I think, the best of all the 5 problems we discussed today. For these 4 problems, yeah, you can easily write, like mathematically you can these 3 first, 1, 1, 2, 3, like write the mathematical formula and guess 3. Fourth are a bit interesting. Fifth one, yeah, it is the most interesting of the problem. So try to spend some time on it. Think how will you define the area of probability, what will the variable area on which the coin must lie, all these parts. Okay. Okay, then see you on another day.